All right, good morning, students. We are ready to do lesson 99, and the new problems for lesson 99 begin on number 1, problem number 1 and problem number 2. Now, if we read that one through there, you agreeing with me, that's going to be a distance problem. A distance. Ferris and Julie, they jog around a circular track that is 500 meters long. Take special note of that 500 meters. Julia's rate is 250 meters and Ferris's is 230. The distance ratio, we have Julie's rate, she went the total distance, and we have the other distance was 1 lap behind. Now, what's the distance of 1 lap? If you look there, it says that the track is 500, so we would put 500 in that case. Here we have distance, and this is Julie's, and this is Ferris, because Ferris ended up 1 lap behind. Now read that carefully and make sure you understand that Ferris is 1 lap behind. Julie is full lap ahead, is what it's saying. All right, so now we have it established here, so we go RT equals RT plus 500. Understand that? Here's Julia's, and here is Ferris. They're giving us the rate of both of them. Julia's rate is 250, and Ferris's is 230. Now that's 2 out of the 3 we need. We need 1 more. Here we have the times of both of them. Now, how are we going to establish the times? They say that they started off together. I'm reading through the sentences here. They started off together, and they actually ended together. Now, one was 500 meters ahead, but they both started and ended at the same time. So we can say that time of J actually equals the time of Ferris. TJ equals TF. So they're interchangeable. When you have this equation, these are interchangeable. I can do whatever I want here with this. So I can actually say RJ, this TJ, I can change that to TF, and then put the TF here, so we have the same names. Does that make sense? All right, let's see how this works out. In this case, we have 230 and 250 to subtract the 2, and we have 20 TF equals 500. 500 divided by 20, I believe that is 25. TF equals 25. What are they asking for? Julia's rate, in how many minutes would Julie be a full lap ahead? 25 minutes. That is one of the more difficult ones we have worked through. I hope you understand that one. We will go to problem number 2. Problem number 2 again is a lesson 99, and it is one from this lesson, so you watch, they're going to be very similar. We've got distance. We have Eleanor started out, and Alexis started out after her. And one of them was 60 miles ahead. Do you see that? So we have distance of one and distance of the other was 60 miles ahead of the other one. We have distance and distance. Which one was ahead? Get you, she's still 6. How fast? Eleanor was the one that was ahead. Read it carefully, make sure you understand that. But if you read all the sentences slowly, you'll see that Eleanor was ahead of Alexi. Okay, so now we have our distances established. Again, we have an RT equals RT, again, plus 60. And we have Eleanor, and we have Alexi. Okay, and we have times on both of them. Eleanor started out at 9 a.m. Let me just do this for you so you understand what we're doing. Eleanor started out at 9 a.m. and Alexi started out 2 hours later. You see that? Alexi started out at 11 a.m. And when we are solving this problem, they say they were doing it at 3 p.m. So we have 3 p.m. on both of them. Now we need to get the hours for the time. 9 a.m. to 3 p.m., that is 6 hours. 11 a.m. to 3 p.m. is 5 hours. That's your times. What is our rates? The hours at 60 miles per, oh, Eleanor started out at 60 miles per hour. So here we go. So Eleanor started out at 60 miles per hour, and it doesn't tell us how fast Alexi was going. Okay, so we have 1, 2, we have 3 out of the 4. That's what we always look for. We'll begin to solve this. I'm going to erase this to get me some room here. In other words, we have 60 times 6. They are side by side. 60 times 6 is 360 equals, and this is 4 RA. I should have brought this down so you understand what I just turned it around. Equals 4A plus 60. Don't forget our 60. All right, so we subtract this 60 off of 360, and it becomes 300 equals 4RA. 300 divided by 4, RA is going to equal 75. Now, what kind of label is that? Is that miles per hour? It is 75 miles per hour. This is how fast. It says how fast was Alexia driving. You note the A, and it says she was driving 75 miles per hour. These are beginning to be a little more difficult. I want you to read those slowly, and tomorrow morning you should have some very similar ones, and so hopefully you can solve them on your own tomorrow morning. All right, we did number 2, 1 and 2. We're going up to 7. I tried to pick out the ones that might give you some difficulty. We have a triangle, and we have to find the missing number. This is D. We have to find D. The first thing you always observe is, are we solving for the hypotenuse, or are we solving for one of the lines off of the square? In this case, we're solving for the hypotenuse, so we square this one and square this one and add them together. 4 times 4 is 16. 7 times 7 is 49. That looks like 15, 4, 5, 65. So this is the square root of 65. Can we reduce that? 5 goes into 65. That's for 5 and 13. We cannot. So your answer for number 7 is going to be the square root of 65. This is not totally new, but hopefully I'm going to do number 8 because this one is a little different. And I want you to really note this because this time they're giving us the hypotenuse, but they're not giving us one of the sides. Very similar, but we have to remember the other one. If you remember, we added the squares. This time, because they're giving us a hypotenuse, we subtract. 12 times 12 is 144. And 9 times 9 is 81. Remember, in this case, we subtract. 4 times 3, 63. So this A is the square root of 63. Now, can we reduce that one? 3, we might can. Let's see here. 63. 3 is 21. 3 is 7. We have a 3 to the square root of 7. 3 to the square root of 7. That was number 8. Going to number 10. You do have the graph. You stamped that, but I wanted to do this morning without the graph. I want to see if you can understand what I'm doing here. 4 and a 3 and a 7 and a negative 2. I will show you how to do this if you did not have a graph. And so we have to, on A, we find the slope, and B, we find the distance. Okay, here's what we have. This is X, and this is Y. Remember that? Okay, we have on the X, we have a 4 and a 7, both of them positive. Now, what's the distance between the 4? 1, 2, 3, 4, I'm sorry. 1, 2, 3, 1, 2, 3, 4, and the next one is 7 on the X line. What's the difference between that? It's 1, 2, 3. So what we actually have is a 3, and then we go to the Y's. That's this, we have a 3 and a -2. This is -2, and that's 3. The distance here is 1, 2, 3, 4, 5. So we actually have a 3 over 5. I should have done this way, I'm sorry. Watch this again. This is on your Y line. I goofed on that one. Here we have a +3, but it's still going to be the same. 1, 2, 3, and a -2. The distance here is 1, 2, 3, 4, 5. So it's a rise over run is a 5 over 3. This is your Y line, 5, and your X line is this. Now, I'm going to solve it just like I should have to start with. I wanted to show you how we can do this. We have a 5 over 3 if we did not have the graph. You do have a graph, so let's go back to this. Place your points. On the first one is a +4 on your X and a +3. This is where your first point is at. The next one is a 7 and a -2, so it's way over here. This is your line. Okay, and again, we're going to make a square out of this, so this would be your point. 1, 2, 3, 4, 5. This is a 5. 1, 2, 3 is a 3. And that again shows us up the same. 5 over 3 is the slope. Is this uphill or downhill? This is downhill, so on A you should have a -5 over 3. Then we want to find the distance. Again, we do this. We have to solve for the hypotenuse, so we square this. 5 times 5 is 25. 3 times 3 is 9. Do we add or subtract? We add these because we are solving for the hypotenuse. That's going to be 34. 34 is that the square root of 34. Can you reduce that to 17? No, you can't. So the distance is a square root of 34. That was number 9. That was number 10. Sorry. And we do have number 11 to do. Let's do number 11 also. This is number 11. In this case, we have the points of 4 and -2, and a -2 and a 3. Okay, here I'm going to place the points. I have a 4 and a -2. Here we go. And a -2 and a +3. Okay. Make sure of this. We went 4 and -2. Went -2 and a +3. There's our slope again. And we want to make a square out of it. Here's a point. We go down, over, 1, 2, 3, 4, 5. And 1, 2, 3, 4, 5, 6. A and B. A is the slope, and the distance. B is the distance. The slope is going downhill. That's going to be a negative, and it's rise over run, so this is rise. It's 5 over 6. This is your slope. Your distance again is finding the hypotenuse, so we square these sides. 5 times 5 is 25. 6 times 6 is 36. 61. Square root of 61. Can we reduce that? I don't believe so. So that is number 11. I'm going to do several more for you. Go up to problem number 25. It may give you a little bit of trouble. We have to get a common denominator. I'm seeing the x's. It's going to be an x squared, and then it's going to be a x positive 4. Okay, solving on the left there for the x that's up here, we have added a x squared to it. So we have a x plus an x squared is an x cubed plus 3. In this case, we've added both an x and an x positive 4. The next one is a negative sign. In that case, we are going to add an x positive 4 only. We already have an x positive 2. We're going to add an x positive 4. Now, this is a little tricky what's going to happen here on this. What we have to do is do the distributive property of all of these and add the like variables. Here we go. Then we'll just redo this. x3 plus 3x, distributive property is 3x squared. Again, this is positive 12x. And in this case, we'll have to do the multiplication here. X positive 2, x times x positive 4. Don't forget this negative sign here when we get all through. X, that's going to be x squared plus 2x plus 4x, running out of room, plus 4x plus 8. I'm going to bring this on down here. It's going to be it's going to be tough here. Yeah, this is x. This is positive x squared, and this is 2 and 4. That's going to be positive 6x, and that's positive 8. But don't forget we had a negative here. We had a negative sign, so that's going to change every one of these signs behind it. Now we have a negative x squared, we have a negative 6x, and a negative 8. Okay, let's combine like variables with their exponents. We have an x3, here's a 3x squared, and a negative 1x squared. That's going to be positive 2x squared. Got a positive 12x and a negative 6x. That's going to be positive 6x. And the number stands alone, negative 8. All of that over top of your denominator, x positive 4. There is your answer. That is a complicated one. All right, and now I had chose number 28 and 29 yet. 28. I don't know why I did 28. I think that's one that you would understand very well. Let me skip that one. And 29, I'm just wondering if you remember the formula for finding the surface area of a sphere. If I'm right on this, it's a 4 times pi times radius squared. Surface area of a sphere. I'm going to check back to make sure I'm right before I work this out. Surface area of a sphere is a 4 times pi times radius squared. That is correct. Okay, so we have 4 times 3.14, and the radius is 4, so it's going to be squared. It's going to be 16. That's going to equal, I'm going to let you do it. I don't have a calculator here. I'll let you do the multiplication and then make sure you label that right. That is all of them I'm going to work out today. You're welcome to give me a call or a text, and I'll respond back to you as best I can. I hope this is going well enough, and if you need me to help you in any kind of way, let me know how I can help you. Y'all have a wonderful, blessed day.